Good morning, everyone. A warm welcome to the inaugural meeting of the Birds of a Feather on HPC and AI. It's a brand new BoF that we are starting on this very, very pertinent and important topic going forward. So the agenda for today, it's just a welcome and the very brief introduction as to what we are doing and how it came to it. And then we have Dr. Pivot Srichakul, who will be giving the invited talk. And then we'll have a session of Q&A with based on his talk and whatever that you have interest in. And next, we will formally form the BoF with the TOR chair and the co-chairs. And then we'll open up the session for a discussion on the way forward with the HPC and AI for APAN and the region. The introduction, a very, very brief one. APAN call for proposals on setting up a BoF on HPC AI in view of setting up a working group later. We, that is Learn or Lanka Education and Research Network, we submitted a proposal which was accepted by the APAN. It was initially planned for APAN58, but we requested APAN to advance it to APAN57, given the importance and the rapidly changing nature of this subject, so that we can start as soon as possible. And we are very grateful that for APAN for agreeing for that and giving us the opportunity to start this from APAN57. Now, looking at setting up the BoF on HPC and AI, or the working group thereafter, I know we see that there are a lot of opportunities that are there. There are a lot of objectives that we have in this. But if you look at the opportunity, I mean, things are changing so rapidly with the generative AI, as well as the high performance computing, the change of technology, the rate of change in technology, and the GPU computing, all these things, we see everything coming together, which has given rise to even generative AI and the possibilities that are there. I mean, Dr. Piyavut will actually talk about these things better than me, but we want to for the APAN community to tap into this, the wellspring of innovation that is happening around the globe, and to ensure that we, our region and everybody in our region is in the forefront of this groundbreaking research and the projects, and also in the same vein, to have a digital equity. We're seeing that, especially if you look at Thai SC, Thai supercomputing, the Lanta supercomputer, they're really in the forefront of in the region. We see it in Singapore with their National Supercomputing Center. We see it in China, India, Japan. But the rest of the region probably is still getting around to what is happening and what are the possibilities. So if we want to ensure that the equity, digital equity in the region, and that everybody would be able to take use of this advancement in technology and use it for economic growth and the societal progress. So that's another important opportunity that we don't want to miss. And also for APAN to become a global leader in the HPC AI area, because as the internet and service providers to the academic and research community, who are actually in the forefront of all the new things that are happening, we want the APAN to take an active role in becoming a global leader in this rapidly changing and changing technology. So that's basically the opportunity that we see at the moment that we are going to take up with this BoF and the working group going forward. So more with that, as I said, there's no better person to talk about that than Dr. Piyavut Srichako, who's the director of the NSTDA Supercomputing Center, or TISC, and the deputy executive director of NECTEC. And he'll be talking on the recent developments of HPC and AI in Thailand. I am extremely grateful for Dr. Piyavut for accepting our invitation, and he had to cancel some other engagement that he had. So we are extremely grateful. Thank you so much, Dr. Piyavut, for taking your time. And I'll, without further ado, I'll hand it over to you.
Well, thank you very much, Asita, for that. Just a moment, let me handle how to share the screen here first. Okay, I know, but it's been blocked.
Yeah. The other screen is actually blocking.
Okay. Share. Okay, I think I'll be standing. All right, thank you very much. And perhaps doing this way is better. Okay, you see, well, I'll just gonna do this. All right. Well, thank you, Asita. Thank you, APAN, for inviting me for this one. Anyway, after being contacted and look at the agenda of this meeting, is actually this is more like a discussion group meetings. So I intended this presentation is not as presentation for presentations, but rather giving some information as the seed for this group to continue collaborations and discussion and talking about how you want to move forwards by using perhaps a Thailand example on this part. And since the work group is going to be HPC AI, and try to I'm from the HPC side, so I'm trying to bring up to see at least how HPC in Thailand has been developing recently, and also what are the role HPC and AI are coming together. And then I think it's better to start that with discussion afterwards. Okay. Great. Doesn't go. All right. Anyway, since I'm here, I better give a little short presentation of where we are, and I'll follow with the timeline of HPC development to today. And let's see, there are in Thailand on the AI side, there's some let's say strategy to put up the national AI strategy, which has been shared by the Prime Minister, and NSTDA is acting like a secretary, and all that try to pave the ecosystem of the AI development in Thailand. All right, TISCs or NASA Supercomputing Centers here is a part of, currently is a part under NECTEC, National Electronic and Computer Technology Centers, which is one national center under NSTDA, National Science Technology Development Agencies, belongs to Ministry of Higher Education, Science Research and Innovation, or MESIs. Okay. The TISC was founded in 2019, commissioned to provide actually a computational resource infrastructure for Thailand's R&D, particularly in computational science and including AI, addressing important issue for that, some ad hoc problem that requires a large amount of computing resources, and promoting the use of high performance computing in okay. Oh no, I don't think you can. It's from my computer, unless the control is in there. All right, great. For giving that commissions, we set up our mission into 5 areas: providing computing resources, perform frontier computational science R&Ds, promoting HPC workforce, roadmap for HPC in Thailand, and partnership and visibilities. So far, with limited resource, especially human resources, particularly right now, operating Thai C, we have currently only 7 full-time staff, and soon will come in maybe even less. We were able to do number 1, 3, and 5 quite good in the past few years. So we are escalating the service of HPC now to a national scale and try to involve and driving the development of HPC task force, workforce and visibility, which has been done quite good. Just a brief recap on history. So high performance computing in Thailand actually started with this term in 1995. NECTEC was starting providing the small scale HPC service using Cray and a graphic over the network, over the internet at that time, which means a slow internet, including the modem bank. I remember that would be maybe like 2400 baud. If some of you know that term, so you are over 40s or 50s. All right, so it's the first online service in Thailand, go together with the network connectivities, and the situation in this type of infrastructures doesn't seem quite a rose garden. So after the phase of that thing is ended, it's just in time that the HPC architectures has changed from a large supercomputer, expensive one, into move toward the cluster computing architecture, which is still very much the generalization architecture of today HPCs. And as that era come to Thai grid, the grid computing term was that era led by our late Dr. Puchong Uttayopart. That was the first large-scale computing resource project, including with 14 members and extended to 22 members in 2008. And again, after large investment on each wave, there's a discontinuity of let's say growth support from the government. Both are actually funded by the government monies. So to the third place, okay, third wave, try to minimize the risk of large investment which discontinue from wave. There's become a sharings. So many university and agency has small scale HPC racks. So come to share through the consortiums. So the consortium is more like a matchmaking workplace. It wasn't organized in terms of having the systematic or autonomous submissions, but rather for the researcher in Thailand who has a problem and looking for the cluster to run the problems, send a request to the consortium and to say, well, which cluster is available, then you have to go deal with the administrators of each cluster. All right. So, but at least it's sort of like a marketplace. Now come to the last phase. Right now, when Thai C was set up in 2019, was actually set up for planning and executing our latest development of the national scale supercomputer Lambda. Okay, so at first the pilot system was invested by NSCDA itself for using as a central and shared resources in SCDA, and also extended pilot to university, government agencies, and enterprise to see how the system of service would work for them, and we use that as the guideline to operate our latest computing. This slide is just going to tell you that our latest system, Lanta, finished implementation in 2022. So, and they start operating for a pilot phase in 2023. So it's 1 year old right now. But the only thing I want to mention to you is before you get to 2032, the whole thing started in 2018. So with plannings, seeking budget, procurement, installment, that's including utility buildings and things that support your supercomputing. So it take well, Tan Jin Wee from NSCC in Singapore told me you need 5 years. I said, why do we need 5 years? Now I see it's 5 years. Okay, so it really is 5 years. So anybody want to do this? Take this as some of the estimation of learning curve, especially when you are living in the area that your budgeting system is like us in Southeast Asia. Oh, that's a basic comparison of the resources on each system. Okay, just want to mention that Lanta, which is the current system, is heavily loaded with GPUs. Why? The design of Lanta was actually done during that phase. And you see that that time, the current system consists of majority of CPU core more than the GPU. But actually, we know that the drive and the growth of AI was actually the logical rationale of driving majority of, I think most of HPC system today in the world, having a very large proportion of GPU. That's only to the growth of AI. I'll tell you later on, there's also, that growth also has something strange after you set up the system and deal with the AI. All right, so that we decide that Lanta have to consist of a large proportion of GPU, which although GPU is actually can be used for many applications, but most people tend to link it to be AI and GPU. but actually it's the growth of that is more. All right, when Lanta finished, now I move to the latest supercomputer in Thailand. I already told you it took a long time to do and a lot of things because we don't have a continuous growth of communities and investment. It has a lot of problems, including the COVID in between. So that's delayed quite a lot of things. When it finished in late 2022, put up the rank and it's end up in rank number 70s in the top 500 and rank 24 in the green 500. Want to mention this why right now you get into this business. Concerns are not only performance, but seem to be another imposed conditions that it has to be environmental friendly, use less energy and things like that. Okay, which is somehow a little bit conflict of interest. You want your computer to be stronger, faster, more powerful, but you want to use less energy. Yeah, two things together is put you in have to be a well-balanced design and looking for the things on the shelf. A year passed very fast, dropped from 70 to 94 and from 24 to 30. All right. And the part of have to be concerned with greens. We have to choose the, let's say, cooling dissipation, heat dissipation method more efficient. Your computer are denser, generated more heat, and the air cool system doesn't quite flush it out. So if I strip off, you know, the good looking and beautiful sticker out inside, you will see that we adopt the water coolings into the computer. That's require a utility side to help out do this one. Okay. So I just showed up. And actually, these are only compute of all the whole racks. Only these 2 racks are computing units. Okay, we expect that adopting this technology of cooling technologies, we should reduce the energy consumptions down to 33%. We're still doing statistic on that, but my rough calculation, there has something more. We are not yet getting there. And the 30% drop of energy consumptions in terms of pricing has been compensated by the gone up of energy price in the world for the past 2 years, which going up almost 50% in total. So, well, it has been tough. All right. I'll just say where the location of that things is, and this specification of HPC. If you are in the area, so you understand, right? We have a CPU core or 30,000. 700. This is not core; it's a card. All right. We have a siblings, brother and sister system in Singapore, Lanta and Aspire. But don't get it wrong. This doesn't mean that is small. It's just that's a Singapore system, heavily embedded with more CPU core. The CPU core is much more than what Lanta has. It's just that it has about half the size of GPUs than the rank, and competition on getting on the list on CPU is tougher. I would say actually Singapore system as a whole is actually larger.
HPC, you have to wait a lot longer. It takes a lot longer to build it, partly because of the availability of the GPUs. They're all run out.
Yeah. Well, it might be still fit in 5 years, because when we install Lanta, we still have to wait for not only the TPU was available, but other parts of electronics are not. So the whole system are waiting. You know, you're missing a 10 screw, then they cannot deliver. So, yeah, but you're right. GPU especially, which I think I look at the investment page a couple of days ago. I think the investment for GPU is NVIDIA has taken pretty much almost the whole market, and there are back orders. All right. When you deal with these HPC infrastructures, most of your users, so these are where when you run this service, you have to take care of all this one. Actually, all of those. When you deal with your users, most of the users interact with the system with the applications. Okay. For some advanced user who write your own codes, things like that, they have to deal with this as well. Perhaps some of these, if they want to compile things into their home directories, they have to learn somewhat how to get on. It's a basic, rule of thumb. Just like when you go check in the hotel, there are certain rules that you need to follow in the hotel. Okay. All right. That things you have to take care of from the ground up, and you have to do a service dealing with your user a lot on this, and things that we have, which is very tough when you have very limited staff. I have 7 full-time staff, as I mentioned. We actually divided our 7 people into 3 groups. Operations, scientific service, supporting service to the user when they have problem of running applications, and the last part is business development. So anyway, we managed to have 7 or 8 temporary staff, but not very highly technical to support us. For a year that we put Lanta in service from March to October, that's the start was taken. When we first opened in pilot phase is basically is free of charge. We open up 4 programs so that people can submit the proposal and select whether it's suitable to run. The Pioneer programs is selecting 10 projects, which supposed to use a lot of computing resources in 3 areas. that we designed. One is frontier science for those performing basic research but use a lot of computing resource. Ad hoc, some short terms that need to provide some outcome or output for the immediate use, and also AI. Okay, we have 10 projects on that, and then we have coming up afterwards. After that, second program we call closed beta test is it onboarding the existing user, your old customer, onto a new system so they get familiar. And open beta test is open to every sectors, industry, government, university, which hasn't been our user before. So they get to know on that one. That was we did the first year. First year is basically marketing the system. And recently also the LLM, once the ChatGPT is out, everybody going crazy about large language model all over the world. So, and it's certainly there's a lot of group that would like to do that. And overall that more than 152 projects. And actually, if I didn't have the stat toward today, which is still in pilot phase, we'll perhaps go into production in this coming March. We have more than 200 research project running on that, and more than 400 user account. Okay, on Lanta only. Yeah, and those are the area that roughly classify what are the job was running on Lanta. So you can see the large proportion is AI and biology and chemistry, the usual suspect in material science and drug design, things like that. Okay, well, since this session is about HPC and AI, so some of the example that put up on the system over here is that improving this related to AI, and of course the Thai GPT, which is a collaboration among quite a number of groups, one including the group in NECTEC with the Association of AI Thailand and Association of entrepreneurs, AI entrepreneurs in Thailand, okay, and a few universities. Okay, right now, of all those programs that we put up, I think similar to everywhere else, the majority of users are university, and now we can say that it's all over the countries. Since this is in APAN, I would like to take some note. The network is also something you need to look into it. All right, our past user in government sectors and enterprise, private enterprise has been using our service of Thai SCs. Okay, other than providing service in terms of human resources, we also supporting the training. One of the good example that I would like to put up as there's a campus of Thammasat University in Lampang, not in Bangkok, which has starting from almost nothing, and by training they get into this competition for 3 years in a row. I think there were first year that didn't get any places. It's missing from the slide, right? But anyway, that's what they do, and they use us as we are supporting the resource for them to train to that programs.
Also, it's very, very useful.
Yeah,
it's very useful, and I take students for competition as well. And last time, Puchong took them for ISC as well. Yeah.
Yeah. Another part is to get awareness. You spend a lot of money on supercomputing, right? HPC is actually a large amount of money, which ran out very fast in terms of computer outdate in 3 years, 5 years. So your $10 million gone to nothing in 3 years, 5 years, right? In terms of values, and awareness has to be one thing that we have to address and to get support, and we need to tell them what does the benefit of this one. So we also open up for site visit, and some of you were including the site visit on was on Monday, right? Yeah. Okay, for over a year and a half, even before we have the system on the ground, but we have the data center and utilities available and the design, the people start asking to see what it is. But certainly that's a small number. But once Atlanta was up in the top 500, the number of visitors and requesting are growth quite a lot. It seems like twice a week we have groups to visit. So we have over 1,000 visitors over the past years. All right, so that's pretty much that. Okay. Now, the other part I mentioned the visibility and among those 5 missions that we have. Being able to put yourself on the map, in the global map, bring you attentions and collaborations. So we have partners, whether it's a formal or informal, that we work together, and also a local partner who use HPC as their, kitchens. And also brought up into a larger collaboration area that right now, I think this month, right? Today is already February. We have a continuous meeting of so-called Alliance Supercomputing Center. So far, there are 15 institutions from 12, I guess, 12 or 13 countries joining. We have a regular meeting about every 6 months or so, online or on-site. But this time we plan on-site in Sydney in conjunction with Supercomputing Asia. Okay, and also once put up as a national scale, we were appointed to be a representative of Thailand in these are a little bit more formal. The ASEAN, which consists of 10 ASEAN member states. So I was appointed to be delegate into this area to join the ASEAN HP Task Force. Was co-chair for about 4 years. I resigned from the co-chairing position last year due to no time, but still remaining on the board. But just to tell you that with that, you bring more collaboration, international visibility, and international collaboration with other area, with other part of the world. Say the example of the EU. Once the ASEAN HPC Task Force was set up by ASEAN in 2018, EU walking in. Let's say that we identify the same need in ASEAN. In ASEAN, decide 2 important things: human capacity, because seems like we are lacking people in HPC experts and application domain. And then, of course, anywhere when you deal with that scale, they ask for impact for the regional application or common application where all the nations should share the benefit together. So that's one of the area that I have been honored to be involved with the human capacity, with working with the EU. Then we set up the so-called the EU ASEAN HPC school as the first time ever of bringing the thing that European has been done like for a week long regularly bring to ASEAN, and we have people in ASEAN joining to that one. And even that is called EU and ASEAN, but actually is bringing in Japan. Japan actually contribute at least almost 1/3 of this school. Okay, and this continue from 2021, 100% virtual due to COVID, 2022 in Bangkok, and 2023, which just passed in December in Indonesia. And okay, we're still waiting for 2024. We just had meeting yesterday. I think Indonesia might have another shot on that one, but we'll be confirmed or announcing later. All right. Just to add things that are not on the slides, the movement of this HPC from Singapore to Thailand. Now there are 2 more major players in ASEAN start moving to come up. Indonesia has also set up the National Skills Service, and also dealing with to be ASEAN representative to put up a new system with collaboration with Korea. Okay, but still under negotiations, right? And looking from the ASEAN HPC school, since 2023 onward, the EU ASEAN HPC school now is called ASEAN HPC school. So like the collaboration help to see the activities, and now ASEAN has to carry on that activities. We can see the major contributions of people from four countries, and also with the collaboration with Japan at Fukaku. Also, we have a program that get the project in ASEAN onwards. You see, active projects come from, well, of course, let's say Singapore, Indonesia, Thailand, Philippines, some of Malaysia as well. Yeah. All right, now how much time I'm doing okay with times? Now let's touch to the part of AI. Okay, it's still two separate entities, except for I just showed that some application on HPC, it's AI on Lanta. But now for Thailand is driving AI. Of course, everybody is doing AI in university, in agencies, in the business. But on the road that NECTEC has been involving is driving the national AI strategy through the committees where the Prime Minister is the chair and NSDDA is secretary. Okay. In a nutshell, Thailand AI strategies, including 5 strategic pillars. Okay. I think it might be better to see this one. Number 1, well, let's say. I think if you might be familiar, the first pillar is on awareness and ethics, infrastructure to support the AI development, human resource, societal use, and economic use, right? Okay. Through innovations and promoting the use of AI in public and private sectors. So those are 5 pillars. We are acting as secretaries, not the one doing it by so on our own. So by just drafting this strategy, there are many agencies involved, and among those strategy pillars, there are designed stakeholders to lead on to execute. Okay. So it's a thing that you cannot do alone in terms of shaping up the whole directions of the nations. Now bring in the relations of HPC. I took this in a very short notice, so it is in Thai, but okay, you can see those 5 pillars. Okay, right? Ethics, infrastructures, human resources, are research and innovations, and also business and benefit. Okay. It has addressed supercomputer as one of the important infrastructures to support these whole activities. Okay. We also have the part that NECTEC is involved a lot is also a program called Super AI Engineers. If you're in Thailand, some of you might be familiar with this term. So it's been done for 2 or 3 consecutive years, and I think last year has been on the program on the television. And actually, those are joined will have 2 or 3 months to work on their firms or at some problems, a real problem for 2 or 3 months, and Lanta is providing the resource, computational resource for that one. It's like a camp.
Oh, what? Sorry.
It's more like a camp. Yeah.
A camp.
Yeah.
You organize you get everyone together, and then you have a boot camp.
A boot camp, yeah. So the camp consists of the camp consists of like a month or 2 learning workshop, but those guys who join actually have prerequisite, so you got selected into the programs. After completing more like a lesson in the class, they get like a project to do. for 2 or 3 months using AI.
Are they students or are they working engineers?
They're from student to working engineers. We found that good numbers are from people working in company as well.
So the company sponsor them.
The company had to sponsor them to spare their time to join.
Yeah. Okay.
Right. Okay. And other stuff as well. All right. Aside from that one, there also a movement in terms of human capacity development with the Thailand AI University consortiums in 2020s. Those are university involvement so far. So if you go back to the strategies, those are part of the strategy in human capacity development. So you can see the more details or that in this website. The design is that each university will act as an AI hub, as a hub of AI on particular domains of expertise. Okay. So and all these universities also have their a certain quite decent amount of AI HPC's infrastructure invested. All right. I think I prepared a presentation for this one, and maybe want to start with the discussion first. But I just want to point out a couple of things. No, 3 things that I observed lastly. When HPC benefit from the AI growth. So people build HPC infrastructure to support AI growth. And when AI users come to HPC, this is very strange. And this is not only in Thailand that I observe. I have asked around of quite a few supercomputing centers in Europe, in other areas as well, that put up a lot of GPUs. Turns out the AI research, AI users, is the last group that adopt the use of HPC. It takes a long learning curve. I think it's because that before we have large-scale HPC available, they have a different way of approaching it, but because you don't have this resource, large-scale resource, they use different way to perform the AI research. It takes more effort on the infrastructure side to get them on board. The only pain point, which I think can be easily solved to get HPC and AI to go together and grow very quickly, is the term of optimizations. It's just the same as anything else. You have a good code doing this, but you want to compete in window of times. Optimization your code or your design work on this large scale is benefit for advancing your research quickly. And that's a pain point in terms of user and infrastructure at this point, particularly for AI. Okay, this is my observation and being confirmed by a few new centers. Okay, but anyway, it's getting along. And this point, Thai C depends so the workload on the groups, the team on scientific user support is quite a lot for this one, because not only AI they have to support, but there are other fields as well. But this is one of the pain point. Second point, everywhere all over the world, HPCs guys are really limited compared to the growth. Now it's popping up like a mushroom around the world. I don't know what it's a trend of coming up, and then you don't have people to run in the center to provide the service. And AI as well. When you say AI, if you look at the business life cycle of AI, they are the part of, at least very roughly, training and deploying. Okay, training, when people say they are doing AI, you dig deep, there's a small proportion who actually do trainings, and large proportion who is doing deploying. Okay, apply AI, so to speak. So that's also way I think is still have a limited groups number of people who actually do, an upstream AI, limited. So That's a part where the HPC get used most. When you want to deploy your AI, you go to clouds. Okay. Third point, when you say AI to benefit in terms of impact using deployment and business, clouds become important. When you have to train your advanced model is on HPCs. HPC and clouds is on different premises. So it's a painstaking for the user. Once you train it and you want to move it to deploy somewhere else, it's not a tunneling through, it's not automatic. It's a problem which has been addressed in terms of problem for many years, but solution is not there. But I think things seem to be better. Seem announcement from the large cloud service provider firm in global, say Amazon Web Service, Google, and Microsoft, seem to put directions quite openly that they are on the wagon of HPC cloud. Okay, but it's work in progress. Okay. Lastly, we are in APAN, and you're doing AI. AI means you need a lot of data. You need to train your kids to learn fast, forced learning, right? And data is huge. Without data, then your model is meaningless. Okay. So network bottleneck has become a problem somewhere. Okay. Look into the problem that perhaps the point where APAN of this work group and the rest of the APAN can address and work together, find the practical solutions. Okay, I will just leave 4 points on that. Thank you very much.
Okay, thank you, Dr. Paywood. That was an extremely insightful and a wonderful talk. And once again, it's I have to thank you. Before moving on to anything, I just want to give a chance to the audience to have to ask questions from you. Any questions that they have? So I'll give you one mic and.
We are sitting so close, maybe. What are the major applications? Those are run by the students. Because as far as I know, in AI, many of the students, they would be learning different models, and where they would not need a high, actually, performance computational facility, but they would need a good teacher to teach them the algorithms, the models, and the application of artificial intelligence. So what kind of application that is used? And then another is, do you offer any trainings on these two things that I have seen in your presentation? One is HPC, another is AI. So do you offer trainings to those universities, student and teacher, to use these facilities? Do you offer trainings?
Oh, okay. Let me try to recap the question.
There are two questions. Yeah.
The first question is what kind of application that university students running most on the HPCs? Yeah. And the second question is, do you need to be a part of a student university to access this?
To train them on this, to train them on the HPC and AI, how to use your facilities. How to use the facility.
How to access the facility, basically.
Yeah.
Okay. Well, the first one, the student that used this much is we found that to be either later year in the college or more majority on the graduate students. It turns out for the student running on the AI is not much. the large proportion that use the AI part of application on our systems are from more of the team that run on the language models. Thailand's strength of AI is very much on the language models, on the NLP base, so to speak. NLP has been there for a long time. Why there are others non-language AI, we have some tech startups using that one as well. But students, as you mentioned, if you're a student in the university, you don't use it that much. So it is professors who tell them to do some things, and generally with more like graduate students. Majorities of, if you see the other areas, biologies and chemistry, which is quite application towards material research, particularly in chemical technologies in Thailand is one of the large portions. Those are also majority of graduate student running the project, falling under the project umbrella of the professors. Okay. That's the first questions. Second questions, how to access this. We service this as a project, so that the PI of the project should submit requests on the portals, describe what do you want to use, what do you want to do, how many resources you want to acquire, and who are the name of the students, professor, or whoever that want to use. So each one of them will be granted account through normal process like another authentications, cybersecurity, VPN password, and granting like that. And this process is used the same, not only for university as this open up. So any government agency follow the same process. Even people inside Thai HC itself, you want to use a system, you go through the same process. Other people, other researcher in NSTDA at Nanotech Center, Biotech Center, MTech Center, following the same process. So we're setting up this standard process. So you got a PI had a project, PI assigns which one, but every one of them go through sort of cybersecurity authentications. Yeah, hope that helps. Yeah.
Have you ever thought of using the single sign-on for access? Then that makes life easier for the universities, people that they're really using their own account in the university to sign on to the HPC.
Yeah, we thought about that a lot, but except for we are not independent, we have go through under central IT facility of NSTDA. So there are sort of many network securities and other security parts. So
because in Singapore we use the single sign-on, and that enables you to quickly get all the accounts up quickly, and for the end user is fine. I'm using my university password and accounts and everything. So immediately you get a large number of possible registrations. Is when you say yes once, okay, I'll click it on, done. It's much easier for you as a HPC service provider as well as for the end user.
Understood. But NSCC,
but you have your constraints.
NSCC is actually setting up as outside,
a separate entity.
Entity. So you can do anything you want.
No. You don't do anything we want, but it makes life a lot easy. And so when NSCC came up, immediately we could get a lot of students registered and everything to use the facility.
Yeah, understood. I hope we can get that too.
In terms of cost structure in accessing the facility, is there a difference between universities and enterprises and other national government agencies?
Good question. Yes. The simple answer is yes, because as the system is tax money, so there we consider the priceless on the levels, and why the Tara system and the Lanta system use different price list and strategy. But in the nutshell, the government agencies and university will pay at a different price than enterprise. Yeah.
Thank you. You mentioned, I'm from Nokia, it's Philippe. You mentioned a few times a challenge in networks. So I don't want to distract from the main topic, but I spoke about this at the dinner as well. What do you mean really? I mean, like, where are the high level challenges on the network side that made you give this remark?
Data movement. I think data transfers.
Right. And is this like within Thailand or within your campus, or is this like interlinked to Asian?
All of those. Let's say in campus with the research on bioinformatics, that's a large amount. But you know, when the two rooms are very not far away, so that your internal network is larger. But since the data is large, it takes some time. Actually, it was quite okay to me, but it doesn't seem to be okay with the users. For the overseas users, yeah, well, we also going to open this up, perhaps as one of the regional system that people can use overseas as well. Then the bottleneck coming through, let's say, how you call it? Between the sides it's the problems, and and in from, let's say, government and university. Government, that doesn't seem to have a problem yet, because they only basically the way we provide service is computing service, so we don't do like a not data business, so it's not transferring all the time. So basically, you get a big chunk. Doesn't matter how long you take the data, it's sitting there. You process, you want the result back. But there's one thing is just funny things too. It's also the understanding what type of data is big. We have one user. I'm not gonna name them. They're gonna use that, and they say, well, what are your transfer rate and things like that? They say our data is too big. It's gonna take too long to transfer. That's in Thailand. So we even arrange that. Okay, why don't you just take your hard disk and come here? We open up the local machine and upload it to you. End up that the data is fit in one thumb drive. So the part of the user, AI user, has a different definitions of big data. The data take a long time to come up, because the data preparation and how to get the data take them a long time to get, and they consider that very big. So when you get down to the ground, I think the understanding how big the data is called big in this one is different. But overseas, like something we try to work out with Singapore, seems like the bottleneck between the countries could be a problem. Yeah.
Thank you for sharing this.
Yeah.
Just giving an example of the importance of network is that because the alliance of supercomputing centers, there are things that are moving between the supercomputing centers. And when you talk about movements, they can be in petabytes of data. And it's not your megabyte or your gigabyte, or terabyte, it's the petabyte. And if you look at it, one way is to bring in a hard disk, but the amount of time you take to copy into the hard disk, amount of hard disk that you have, the amount of freighting it out on the other side, and then uploading it. Yeah. And we found that one of the issue was actually the supercomputer centers have to have data mover nodes, which are tasked to actually move data fast. It's not your general node. They're tuned up to move it fast enough. So that's something that you have to be a bit careful. It's not just lock in and just transfer. That will kill everything already. And even in Singapore, the researchers from my university transferring data to the supercomputer center, they say it's slow. And part of the reason was the firewall throttling, throttling things, you know. And so we set up a science DMZ for them to move it very quickly. And we did it 10 times faster in the gigs, you know, and without much tuning, and just setting up a science DMZ for them to move that data quickly. Yeah. So sometimes even you're close nearby, you think, okay, using a campus network, I'll do it. But the campus network is a general network. It caters for everyone, the small little packets to the large packets. So when you mix them up and drive it like that, then it slows things down, and the university will start imposing, hey, you know, I got a firewall to protect everything. So I throttle anything that seems to be pushing very fast, I'll throttle it a little bit. Yeah. Yeah, and you disturb other people as well. Yeah.
Okay. Thanks a lot. I mean, sorry to interrupt, but it's so interesting, and I think there are so many questions and so many things to discuss. Unfortunately, we have limited time, so I mean we can see the interest in this area. So we'll just quickly move on to the official business of setting up the BoF, and come back to, if possible, come back to have any other questions answered, as well as, of course, Dr. Pierre would be here for a little bit more even after the session. Thank you, Dr. Pierre, once again, in appreciation, we have a token of appreciation for you. May I invite Professor Roshan Raghul, the CEO of Learn, to present it to Dr. Pierre. Okay. Right. Yeah. I mean, so we can see the interest, and of course, we hope going forward there'll be a lot of interest and activities for us to get into. So let us get on with the forming the BoF officially. We'll take it very quickly, right? So the scope is that the HPC AI BoF will encompass discussions and in the initiatives related to the advancement and application of high-performance computing and artificial intelligence within the APAN network. This includes, but not limited to, research collaborations, technology sharing, capacity building, and the development of innovative solutions to common challenges. So basically, to look at the objectives of looking at the TOR, first of all, the objectives. First is to connect and inspire, build a collaborative platform for the HPC AI experts in APAN to share knowledge, tackle challenges, and drive innovation. Upskill the workforce, you know, as Pia would mention, it is one of the key challenges moving on to HPC and AI. So having training programs to researchers and practitioners with the essential HPC AI skills. Bridge the HPC AI divide, once again, as Pia would mentioned. Even though the HPC is like the main requirement, or the computing power is the main requirement for AI, there's a huge divide, especially probably, as you know, as Dr. Pia mentioned, because AI community has moved on with different solutions over the line. But now with the trend of technology, we hope that we can actually bridge the divide. So actually with this intention, we initiated a conference on HPC AI last year at APAN57 in Colombo. So we hope to continue with that as well. So in Pakistan, in APAN58, we are hoping to have it. So there's flyers of that. If you're interested, you can take this and share with your colleagues to be part of the conference as well. And ultimately, any of these things, you know, the whole objective of doing anything, you know, as Peter was once again mentioned, spending tax dollars or tax money of people, it's to, I mean, it has no use if you just do it without economic growth. You know, that benefit has to go to the people. So we hope that, you know, with riding this HPC AI, and by looking at, you know, providing solutions and solving challenges in healthcare, education, sustainability, and many more areas, and also drive innovation to again for the economic growth with, like, you know, things like new drug discovery, climate change, disaster preparedness. I mean, there are many things, applications that you can see where there's a lot of innovation can happen. So to drive all this, now that is the objectives as we see. So the participants, we are looking to gather from all different spheres, the researchers and academicians specializing in high performance computing and artificial intelligence, people are who already working in this area, and also representative from APAN members who are interested in development and applications of HPC and AI in research, education, and all the related areas that comes with the APAN umbrella. And also the technology enthusiasts and the professionals seeking to contribute to and learn from latest advancements in HPC and AI. I mean, as in yesterday's session, you know, Taiworis was asking, you know, how can we use this one? What is the benefit for me? So that's type of thing, you know. I mean, you don't have to really go and understand how to do those things, but how can it help me? So that's the other aspect of we want to look at. And industry partners providing solutions, definitely, because without them, without the technological advancements, we can't move forward. And also the policymakers who will come up with the policies, as again in the Pierwood's presentation, the number one is to awareness and coming up with the policies and the rules that are related with that one. So those are all important aspects of this, so that we are looking to gather everybody under one platform to discuss all this and come up with the what's going to happen. And about the meetings and reporting, we plan to have regular meetings biannually during APAN meetings, you know, with the start of this one. And also additional virtual meetings and engagements as needed, especially in HPC AI area, which is moving very fast. We can't probably wait for 6-7 months or twice a year just to, you know, have meetings. So probably we'll try to have more meetings, and we'll report this to APAN and the membership for them to know what's going on. And then moving on to the chairs and co-chairs, I was thinking about, you know, how to have what kind of co-chairs to have in what capacity, because we want to look at how we can advance the operations as fast. So I was looking at two options. One is the topic-based one on AI and one on HPC, or the objectives-based, you know, people to connect, bridge, and inspire. One on capacity building, probably in applications of research and education, and looking at the regional economic growth. So this is one of the things that we need to kind of come up with, you know, how many co-chairs to have, or in what areas. So any suggestions, any proposals anybody have? Or Vienna? Yeah. I mean, do we need to have multiple co-chairs so we can decide it?
It's up to the working group.
Yes, exactly.
Yeah.
So I'm asking,
Let's say
you know,
you have the easier you manage.
yeah. Give us the best practices, so your recommendation.
One chair, maybe two co-chairs.
Okay.
Yeah. So that should,
All right.
that should
Okay. Okay. Yeah. Anyway, so since we don't have time, maybe we can think about this and identify what needs to be done and decide exact numbers by the next APAN meeting, right? So we'll go with maybe two co-chairs for now, right? So first of all, first thing is adapting the TOR. So that let me. Why is it not moving? So which I presented, I also have it. Okay, so the same things I showed in the slides, draft reference terms of reference for the bird of feathers, the objectives, target participants, roles and responsibilities, meetings and reporting. Any suggestions, updates, or changes needed, or can we adapt as it is? Okay, thank you. So we move on to the next task, which is appointment of chair and co-chair, co-chairs. As we discussed, we'll have two co-chairs. So nominations for the chair. Someone we need some.
Do we need to propose a chair?
Yes, of course.
Propose Asita to be chair?
Okay, any other proposals? Okay, okay, so thank you very much, everybody. And thank you. And can we appoint two co-chairs as well? Can we have some names, please, to go ahead? It's, okay, so we'll okay. Okay, sure, we'll do that. Okay. Sorry. Okay, yeah, okay. So we'll announce and we'll get nominations and we'll. Um. 1 and 4. Yes, exactly. Yeah, that's what I thought. Okay. So we'll come up with after the things, just to wrap it things up, right? So we'll announce and we'll work on that. Okay. So once again, thanks everybody. Just a quick look at what we have in planned or what we proposed in our plan. Just to very quickly go through that one. So we have established the BoF and kickoff meeting is here. And also bring all together, providing the communication channels where we can actually appoint the co-chairs and also get it going. Look at the joint initiatives that we can start at the moment, and also develop a white paper to identify the key challenges and the opportunities for HPC AI adoption in the region. As I mentioned, we'll move ahead, move along with the hosting the HPC AI conference annually. So we'll have it in Pakistan in APAN58. And at APAN58, we'll do a review, retrospection, and future planning. So so that we can move ahead with establishing the working group officially next year, APAN, hopefully moving forward. And we can start things like knowledge dissemination and skill development, continue with the HPC AI conference, maybe things like organizing hackathons, innovation challenges for developing the young researchers and the workforce, collaborate with the regional funding agencies and the building partnerships with the industry players and international organizations, moving on to developing the policy and guidelines, the sustainability of these initiations, publishing research papers with the success and sharing the success stories and how to move forward along that one. So year 3 and forward, we hope to continue with those, that one. And of course, we are running out of time. But if you have any questions as to we will move this discussion into the online forum as to how to move forward while developing the white paper. We'll have a online discussion as to how we can move forward with HPC and AI with the support of people like Dr. Pierwood and Francis and all that. With a lot of experience, we can actually come up with the way forward for the entire region as to how we can move forward. So with that, I'll wrap up. And once again, since Liana and Sean was not here, thank you so much once again for coming up with this call for proposal and also accepting our proposal to actually advance it to APAN57. So thank you so much for initiating this one. You deserve a big round of applause and a gratitude for doing that. So thanks again, APANSEC, for doing this. Thanks all for attending. I hope this will be a beginning of a new era for APAN and the HPC AI community and the regional growth through that for the entire region. Thank you so much, and we'll meet again in APAN58 with next BoF.